All right, so we're going to go ahead and get started. So first off, good afternoon. I'm Jason Thomas, project engineer here at America Makes, and I'll be your host for today's America Makes TRX webinar series. Just a little background on the series before I introduce our speaker. As America Makes continues its mission to expand and accelerate the footprint of additive manufacturing and 3D printing, this medium called the America Makes Technical Review and Exchange webinar series was created. By creating this platform, it allows the additive manufacturing and 3D printing community to come together to share knowledge and experience with the broader community. If you or your team are interested in presenting during the TRX webinar series, please navigate to the America Makes webpage and complete the request form under our membership or events tab. You can also contact the America Makes TRX webinar series administrator, Jason Thomas, directly. A few important notes before we kick off the series. At the end of the presentation, there will be an opportunity for a brief question and answer or Q&A session. If during the presentation you do have a question, please submit it in the Q&A space and I'll ask it during the Q&A session. I will do my best to get all of your answers or questions answered. All right, so today's webinar is on Launch in 3, unveiling a product in minutes, not months. So without further ado, it is my pleasure to introduce our speaker, Matt Cameron of Spokbee. Matt Cameron is a driving force behind Spokbee, a groundbreaking platform that's redefining the way products are launched in the digital age. With 10 years in the tech industry, including application engineering at Stratasys and teaching design for 3D printing at MIT, his passion for innovation led to the founding of Spokbee Inc., a VC-backed startup speeding up product development by a factor of 10. Mac, I will now turn it over to you and your team. Go ahead and take it away.
All right, thank you so much. I appreciate it. So just double check that my screen can be shared.
Yeah, I think everything looks good.
All right, you guys can see the screen?
Yes, I can. Looks good.
Okay, fantastic. All right, well, thank you so much for having me. We've been members of America Makes for about a year and have enjoyed our time there. A big fan. I've been following America Makes since the very beginning when I was working over at Stratasys about 10 years ago. So thank you for having me. And I really look forward to connecting to some of you guys if you guys are interested in learning more. A little bit of more background on me. So again, I was working at Stratasys, applications engineer. I'll go into more of that. Also had opportunity to start the first 3D printing class over at the University of Minnesota, and then start and teach the first design for 3D printing class at MIT. And I'm constantly asked when I'm, presenting and teaching these classes, like, what is my favorite thing that I've 3D printed so far? And I have to say that it's still this real life-size model from my MRI scan, 3D printed to scale of my bone structure. It's kind of creepy. I keep it in the back room, but I've really just been an admirer of the technology, and I've had been fortunate enough to have some really, really cool opportunities like converting my MRI into a 3D printing model. So about 10 years ago when I was at Stratasys, this was the look of our red-eye manufacturing facilities. This was the on-demand manufacturing. We had a similar facility like this with equal or more machines. And as application engineers, we were in charge of keeping these machines running consistently. So we were seeing a glimpse of what mass production and different applications were looking like with 3D printing. This was about a decade ago. So just kind of going through some of the interesting applications that I was fortunate enough to see and work on, from automotive, bodies that were used in actual cars to break records of, efficiency, seeing the first 3D printed castle, which was about 15 years ago over in Excelsior, Minnesota, from very large and very small products, bone structures, big, fun display models, a 3D printed gun in which the components, majority of the components were 3D printed and have, printed shot hundreds and hundreds of rounds, furniture, medical models, casting molds, robotics, full color biological products and consumer products. So I felt like I had a really amazing opportunity to see and explore and work on different applications that, and really just learn how they were made. To summarize the benefits of additive manufacturing, I mean, I'm sure uh, many of you guys, could come up with these as well, but it's still, for the past decade, design flexibility, rapid prototyping, customization, waste reduction, toolless manufacturing. And to me, while I was working on these, an application of 3D printing that I really always wanted to see was mass customization. An ability to be able to launch huge amount of customizable products at scale, and really just make it easier for the average designer or a company to be able to take advantage of this. So one of the very early applications that inspired me to really know that this was possible was a group called Nervous Systems. These were a husband and wife out of MIT who were doing research and created a lot of really interesting software that really inspired me to see, like, wow, this really is possible, right? In this model, we are seeing the modification of a few slider bars. The model is entirely changing, right? It's got this organic shape, but the whole concept behind this is you could have hundreds of thousands of combinations, trillions of combinations of this product, right? Everything is 3D printable. Everything can be manufactured on demand. And, really with a little bit more, power behind this, the price could actually change, in real time. So you have this ability. I learned a little bit more about this, and turns out this one is very, very complex to actually launch. It's not as though anybody can go in here and launch this. These were programmed products from scratch. So I did a little bit more research. I was learning about the the opportunities in the field, and really wanted to dig into the design software. I wanted to learn everything I could about the different design softwares out there. So that's I was in Boston at the time. I had the opportunity to teach this design for 3D printing class at MIT, where I would take a semester long, open to anybody in the college, undergraduates, grad students, and we would go through these different technologies and softwares and try to push them to the limits and see really what was possible with the design software out here. So here are a few of the products, or a few of the things that some of the designers had built. We have various technologies and software represented here, from generative design software to lattice structuring software to surface modeling to clay sculpting software modeling. And the beautiful thing about additive manufacturing is once you have that file, you can make it real. And in addition, once you have that file, there are a whole host of companies out there that are able to manufacture these products on demand. So me and my co-founder, Karina, we drew up a really simple kind of structure of how a mass customization marketplace, right? A way for us to quickly be able to launch products that could be customizable and manufactured on demand. And this was really the foundation of Spokbee. You have a 3D model viewer, you have configurable products. Those products can instantly be kind of shopped out to manufacturing service bureaus. We can get the price back based on volume, based on complexity. We can re-render that model, so we get to see that new model and the price. You choose the quantity, material. If you want to purchase it, you can purchase it. That goes back to the manufacturing service bureaus to fulfill, and that product stops. So that brings us back to where we are today. So Spokbee, unveiling a product in minutes, not months. So to start, just very briefly, what does that process look like? So we've built out our team of SpeedCAD experts. So some of the fastest CAD designers in the world. But the first process to essentially be able to launch these products quickly is you got to have the model. When doing configurable models, a solid body CAD system makes it very easy to kind of transverse different manufacturing methods. So if you're using a software like SolidWorks, Onshape, Fusion 360, something that's giving you solid engineering models, not only can you get prices and manufacture it with 3D printing, but it also lends itself to traditional manufacturing, machining, and whatnot. So being able to design that part, in this case, you can kind of barely see it because it's a little blurry here, but adding configuration variables, which means every single dimension in this entire part is 100% defined. We don't have any internal geometries or surfaces, right? Nothing is designed in a way that can't be manufactured, right? We have certain thicknesses that can be, abided to. Everything is fully defined. Having this model is the first step in being able to launch this product, very quickly. The next thing, this is where the Spokbee app comes in. We allow for essentially the direct single point of truth from that CAD model into a system that allows us to price and build out a customer-facing storefront for that. So being able to choose manufacturing method, choose a couple materials, whether those materials you might 3D print the casting and then cast it, say, out of a precious metals, choosing the materials. And then directly from there, we're able to pull the data, pull the volume, pull all of the information that we'll need from that CAD model, the designs, the weight, the dimensions, and then we can automate the creation of the storefront and the pricing based on volume. It certainly gets more complex than this. Not all of them can be launched, in seconds here, but jewelry is a good design that actually happens to be quite complex to get, the dimensions exactly right to fit on your finger as traditional manufacturing does. But as you see, as we're making modifications, we're able to essentially slide the material cost, right there. So when somebody purchases the product, the manufacturing and fulfillment process starts through one of many service bureaus, depending on who's able to do that, materials, and so forth. And through this process of building, this interface between the CAD and the manufacturers and the digital renders and being able to kind of customize, we actually learned that manufacturers are losing money every year from a number of things that our software is really good at solving. Something that wasn't quite obvious when we first started, but became obvious after. So many manufacturers have all these amazing capabilities, right? Whether it be in-house 3D printing of certain types, or bending and assembly. Manufacturers have the capability to go directly to consumer, right? There's this whole industry on drop shipping, for example, right, where these manufacturers are losing out on a little bit of margin by essentially people buying in. So by building up a configurator, right, linked to the engineering software, which gives your manufacturing team the information that they need to manufacture a custom product, we can actually reduce reliance on distributors. A lot of customizable products, and you'll see this in, I would say, distributors doing both customized and not, is there are product catalogs, right? You'll look at a product catalog, it'll give you the details and the specs, but these product catalogs can only show so much data. And I'll talk a little bit more about ghost products, but by having a product configurator, we're actually able to have a kind of consistent single point of truth between the engineering files, the things that can be done, and product catalogs. Also, gaps in need-based selections. So if you're looking, maybe through McMaster-Carr and you're trying to find, the perfect thing, right? Let's be honest, most likely you'll be able to find it, but every once in a while, you might want something cut, just very specifically, and you don't want to go and talk to, a salesperson to do this. The specific product that you're looking for that is not represented on, one of these kind of spreadsheet-like brochures would be considered a gap in a product that could be made by the manufacturer but is not displayed. Also, there's additional, inaccurate quotes when somebody's trying to quote a complex combination, or a customer is talking to a sales guy and says he wants, a smaller set of casters so it can fit through something as opposed to a larger set. This is a lot of times is done manually today. Again, a problem that we didn't foresee being able to solve at the very beginning, but very much are solving now. And then finally, just delayed product launches. When you have various products kind of all over the place, in different intranets or file structures, it can actually be quite time consuming to launch new products, get everything organized, get manufacturing and everything ready. So selling custom products, right? A lot of times we're seeing call for quote, you can't see it until after you buy it, right? Engineers don't want to create a 3D render until you pay, because it takes them time, right? You get salespeople asking for their engineering team to look at it first, and they don't think that they can do that, but maybe they can do that. But with the product configurations, the single point of truth, we're able to give manufacturers a custom portal with real-time pricing, single point of truth between engineering and sales, data and insights of engagement with a product configurator, something that really can't be done when somebody's just downloading a PDF of different products and configurations. In fact, we can actually see what people are building, and maybe where they get stuck, or if they're configuring a product that just can't be found somewhere else. And being able to handle these customizable products quickly, by again streamlining the process from the configuration and the purchase. So a few examples that I'll just quickly share. We have StoreLock custom workbenches. Their customers can essentially design the shelves themselves. These are workbenches that you would see manufacturing shop floors or various things. There are infinite amount of combinations. However, there is a limited amount of instructions. We're able to incorporate all those again within the CAD model. And this is essentially a 24/7 sales channel with every single product as it relates to workbenches for StoreLock, with custom pricing and modification. A nice, beautiful render. And we have Alba Racing, which does custom ATV rims. They can launch their products 10 times faster with Spokbee's help. We're able to organize a lot of the prototyping that ultimately go into billet manufacturing overseas. And I do foresee as additive manufacturing gets better, more consistent and less expensive, they will actually be able to launch products directly with 3D printing, with configurations as the way to do that. So talking a little bit more about Ghost products and the configuration. So taking all of the StoreLock models, being able to incorporate rules-based modification and linking it directly with the engineering CAD, we can create the work orders, and we can essentially create interfaces that are much more engaging and realistic for customers than the online catalog. Again, this acts as a digital salesperson, but also allows us to launch products very quickly. Right, once we have the instructions and the manufacturing limitations of StoreLock manufacturing, pulling out the inserts, for example, is very quick to launch and create another storefront on their site. Alba Racing, faster product launches, much better communication, and new product lines. So I'll show a little bit more about this, but to essentially be able to change between a 5 lug and a 6-lug ATV rim. You know, different colors between these rims. This configurator doesn't have a trillion options because these products are manufactured in a very certain way. But displaying all of their products on one just very efficient interface, and internally to be able to click through, customize, and be able to prototype different variations has been beneficial for them. Okay, so I want to show just a quick couple of demos here. Let's see. I want to make sure that my entire screen is being shared as opposed to just one window. Can you guys, somebody confirm that you guys can see the Onshape doc here?
Sure can.
Okay, excellent. Thank you so much.
Mhm.
Okay, so this is our engineering CAD. Again, I would say I'm a 7 out of 10 in terms of speed, but my team brings us up to about a 10 out of 10. But I want to show you just a quick interface of, I'm just going to kind of re-update this, of how, the Spokbee app works, and, from that design into, storefront, and what that will look like. So if I'm in the engineering software, in honor of Thanksgiving or Valentine's Day, I'll do kind of just a simple heart design here. I'm going to do this out of a sheet metal. So I'm going to thicken my part. It's going to be 1 millimeter thickness, 1 millimeter bend radius. And I'm going to create just a few simple bends in this. So let's just do 1 bend, just creating my bend line. And I want to bend this piece of sheet metal here. All right. So in the design, I can choose, the bend radius, for example, and I'm sure you guys are all laughing at me to say like, oh my gosh, this is like the, worst thing I've ever seen, but it's for the demo. So what I can do, and what's very interesting, creating, configurations to really take one product and make it 1,000 products, is being able to parametrically configure your part. So within Onshape, this is the CAD software that we built Spokbee on. We love it. It's easy. It's cloud-based. Never crashes. I'm just able to do some configuration inputs. I'm going to do a minimum and maximum bend radius. And I'm just going to configure this part studio here. Edit this, and instead of saying a default, I'm going to add it as my configuration variable. So now I can take this away. I can remove the planes, and we'll just like edit this appearance to be like this. So now as I modify my degrees of this bend, we're seeing my product just quickly bending on this. I have a minimum and I have a maximum, but even if I wanted to do very small changes, I have that capability to do so. So then the interface that we are building, what we're very excited about, is directly within the CAD. Again, this gives us the single point of truth. I'm just going to fill in a few pieces of information. This is essentially building out a online store, which could be both publicly available or internal. I can, let's see this. Just gonna grab an image. I'm just choosing the increments of a slider bar right there. Let's say I want laser cutting. I want this to be out of aluminum, just to show kind of a render. And for public-facing documents, being able to choose a margin. So if I'm launching a product directly from CAD, again, single point of truth, there are advanced controls for pricing, but the simplest way is essentially we take the manufacturing price that we're able to get from the services. We're able to add the designer margin to it, which is here. And then we essentially, Spokbee adds a commission on the parts, and the products can be launched. So directly here, we're able to see this model. We have, a more realistic render. We have the configuration variables that will update that model in real time, right? Once pricing kind of algorithm gets going, we get the pricing for this, and right there in real time, we're able to see a configuration and a storefront. This ends up living on Spokbee, and again, those products can then be manufactured on demand. So as we get a little bit more complex to complex configurations, again, this is our one that we're doing for elbow racing. Even configuring things like the color. So you could choose 10 colors, or if you wanted to give customers the ability to modify colors, different lug counts, by having everything parametric. We're able to have 6 lug, 5 lug, 4 lug, intersections within this, pocket styles of a rally pocket or a pro pocket, and various combinations of this. So again, being able to have that freedom to be able to modify and check, and then we're building a custom configurator for these guys right now, has been really awesome. So I am going to kind of leave it there, put a lot of information in that, but I think what I'm most excited to hear are just questions and thoughts. I think we have a very powerful software and tool here, something that I wish we would have had when I was at Stratasys. A CAD link directly to the 3D printer, no bottleneck in terms of getting the files that you need that are 3D printable, consistent, and frankly, a digital asset that could last as long as you want to keep that product up. So I'll leave it there. Thank you very much. Happy to take some questions.
All right. Let me just get this up real quick here. I want to put Max. Just one moment. I want to put Max contact information in case anybody does want to reach out. Get it full screen, but I have Max contact information there on the screen. So yeah, so now we'll head into the Q&A. So if you do have any questions, there seems to be an issue with the Q&A. I couldn't get it to open. So if you do have any questions, go ahead and please put them in the chat, and I'll ask them. I do have a couple of questions here. So Mac, we'll go ahead and start out with these. So what industries or sectors do you think stand to benefit the most from this technology?
So if a product can be 3D printed well, we have the capability to jump right in. And I would also add laser cut. So that industry in general, I would kind of group together as custom manufacturing. We've also seen a lot of traction within the automotive space. This is lots of parts, lots of hard parts without electronics. Certainly we can consider different electronics, but yeah, we're seeing automotive, industrial, and manufacturing, guides, assistants, jigs, fixtures, tools that can customize based on new products. Those are the initial industries.
All right, great, thank you. All right, so let's see. So can you talk a little bit about how you are linking to the manufacturers? For instance, are you only getting quotes from Stratasys or multiple quotes from other companies?
No, we get multiple quotes from other companies. The really, when I was working at Stratasys, the biggest challenge that we faced as application engineers inspiring people to try out 3D printing was the lack of kind of CAD tools within the communities that we were working in. We would sell dozens and dozens of 3D printers, and they would have one person who is using an outdated CAD tool that doesn't create, parasolid files. So we spent a lot of our time, designing and working with designers and updating designs. So the beautiful thing about just having a foundation in an engineering CAD tool is once you have the parasolid file, the step file, certainly you can get the STL file or the 3MF file. We can shop that around to manufacturers and service providers very quickly. It's essentially what everybody needs in order to provide a quote to 3D print anything. And this goes from metal 3D printing to candy 3D printing.
All right, thanks for that, Mac. So, just another quick question. So I saw the jewelry in the beginning. Is that like solid gold, or is that something that has been printed and then plated?
Yeah, great question. So one of the services that we work with, they actually will make jewelry out of solid, well, 14 karat gold. You can also do it out of sterling silver. And then the process that they use is they'll take that step file directly from the CAD model. They love them in CAD models as opposed to, say, building something in a surface model where you might have these internal geometries and they have to sit and fix it in a secondary software. They'll 3D print those out of wax, and they will use those wax patterns to create investment casted molds, and then they will cast in the 14 karat gold into it. So this is real material.
Very neat, very neat. All right, so let's get another one here. Is this a manual connection to the manufacturers, or are you automatically tied into their website?
Great question. Currently, we're automatically tied with a few of them. For us to get the best price and the most kind of consistent finish of products, we are doing a little bit of that manually now. However, the future is a direct connection. There are a lot of pricing algorithms that go into this. Every service bureau has different prices. If you guys are familiar with the differences of 3D printing with a fused deposition modeling or a fused filament fabrication where you have a filament of plastic and you're printing it out, the pricing of that is a lot different from, say, a multi-jet fusion 3D printing or a selective laser sintering process where with the FDM, essentially, if you're printing one part, you can kind of gauge the price of every single part if you just have one. Whereas if you have a selective laser sintering or an HP multi-jet fusion machine, one part might be the same cost as two parts, and only just if you get 100 parts, your per part cost goes down significantly. So depending on the material, depending on the manufacturing capability and the technology that's used, the pricing essentially follows different curves, and those curves can have steps, and we can incorporate those steps into the pricing algorithms.
All right, thank you. All right, so let's go one more here. So, thinking about kind of where we saw the rings changing shapes and things like that. Does the customization go so far as to be able to add names or wording and things like that to your files?
Yes, absolutely. CAD, so design and specifically Onshape and some other solid design softwares are very capable. Most industrial products we've seen, we see today are designed in these softwares. So if you can essentially, if you see a product that's out there, the capabilities of these softwares can build that. So fine text, pattern, various patterns can all be created in those very easily, yes, and configured as well.
All right, great. Thank you. All right. So I think that's going to do it for the questions today. So yeah, Mac, thanks for the great presentation. Very, very powerful software. That's going to wrap up today's TRX webinar series. I would like to thank Mac once again. If you do have further questions for Mac, please reach out to him directly. His contact information is here on your TRX webinar screen. And as a reminder, if you think you or your organization will be interested in sharing on the TRX webinar series, you can go ahead and navigate to the America Makes website and fill out the webinar request form, or you can reach out to Jason Thomas at jason.thomas@ncdmm.org. Thanks very much, and everyone have a great day.
Thank you so much.
Thanks for coming, everybody. And thank you, Mac.
Yeah, thanks for having me. That was great. Hopefully there were some people who learned some things, and yeah, appreciate you guys putting this on.
Yeah, most definitely. Appreciate it. Have a good rest of your day.
Awesome. Cool. Cheers.